Hey everyone, welcome back to the channel. In today's video, we're diving into something essential in EF Core, many-to-many relationships. Now, this is the fourth video in our EF Core series, and if you haven't seen the previous ones on one-to-one and one-to-many relationships, I'll drop the links in the description below, so you can catch up. But today, we're focusing on many-to-many relationships, which are pretty common when you're building systems like e-commerce platforms or social media apps. Stick with me, and let's get started. Before we jump into the details, I want to give a quick shout out to our sponsor, Entity Framework Extensions. If you're looking to boost your EF Core performance, Entity Framework Extensions makes it super easy to insert data 14x faster, reducing saving time by up to 94%. Check out the link in the description to learn more about how you can optimize your database operations. Alright, now that we've got that covered, let's talk about many-to-many relationships. This type of relationship occurs when one entity is related to multiple instances of another entity, and vice versa. For example, in an e-commerce system, an order can include multiple products, and a product can appear in many orders. This is a classic example of a many-to-many relationship. So, in a many-to-many relationship, we need to model both sides, meaning both entities reference each other. Now, under the hood, EF Core uses a join entity to keep track of this relationship. You can let EF Core create this automatically, or define it explicitly if you want to customize it. So in our case, we're manually defining a join entity called order product to model the many-to-many relationship between order and product. This join entity includes foreign keys to both sides, one to order and one to product. Instead of each side having a direct collection of the other, they now each have a collection of order product. This gives us flexibility to include extra fields like quantity or unit price. Let's take a closer look at how this is set up in code. First, we'll create the product entity to hold product details. Then, we'll define the order product join entity to link both order and product. Let's start by defining the product entity. In the product entity, we're going to define three properties: ID as a GUID to uniquely identify each product. Then, name as a string to hold the product's name, and we initialize it with string, empty to avoid null issues. And finally, price as a decimal to represent how much the product costs. Alright, we've defined our product entity. Now let's go ahead and define the order product join entity to connect orders with products. First, we have order ID of type GUID, which acts as the foreign key to the order entity. Then, we define the order navigation property. This gives us a direct reference to the related order entity that this record belongs to. So instead of just knowing the order ID, we can access the full order details through this property. This is useful when we want to load related data, like when displaying all products within a specific order. And assign equals null to suppress nullability warnings. Next, product ID is another GUID, and it serves as the foreign key to the product entity. Now we define the product navigation property. This gives us access to the full product entity that's linked to this particular order. So if we have an order product record, we can easily navigate to the related product and see its details, like name and price. Just like before, we use equals null to suppress compiler warnings. Alright, now we've finished defining the order product entity. This class acts as the join table that connects order and product in our many-to-many setup. Next, let's go back to the product entity and add a navigation property to hold the related order product records. Here, we define a property called order products, which is a collection of type iCollection. This means one product can be associated with many order product entries. Or in simpler terms, this product can be part of multiple orders. We also initialize it with an empty list using equals, which is shorthand for new list order product in modern C#. This helps avoid null reference issues when working with the collection. Now, with this navigation property in place, EF Core knows how to link each product to its related orders through the join table. Now that we've finished setting up the order product class, let's move it to its own file to keep our project clean and organized. Next, let's hook up the other side of the relationship inside the order entity. I have copied the order products property we used in the product entity and pasted here inside the order class as well. Since both order and product are connected through the order product join entity, they both need a navigation property to that class. Now we need to make a small but important change inside the order entity. Previously, we had a property like public string product, or maybe even a direct reference to a single product entity. Since we've now defined a proper many-to-many relationship using the order product join entity, we no longer need that single product property. So, I'm going to remove that property to avoid confusion and make sure our model accurately reflects the domain, where an order can have many products and a product can belong to many orders. Alright, we've now set up all the required changes and created our entities. The next step is to tell EF Core how to handle this many-to-many relationship. We'll do that inside the OnModelCreating method of our ApplicationDB context class using the Fluent API. This will give us full control over how the relationship is mapped in the database. First, we define a composite primary key for the order product entity. Since this is a join table, it needs a combination of both order ID and product ID to uniquely identify each record. This tells EF Core that the primary key for this entity is made up of both order ID and product ID. This setup helps prevent duplicate entries, so you can't accidentally add the same product to the same order more than once. Next, we're going to configure the relationship between order product and order. Here, we're saying that each order product record is linked to exactly one order. That makes sense. Every row in the join table must belong to a specific order. So we're telling EF Core to expect a reference from order product to order. Then, we complete the other side of the relationship by saying that an order can have many order product records. Finally, we specify order ID as the foreign key. This is the actual field in the order product table that EF Core will use to connect each entry back to its parent order. Now, let's do the same thing for the product side of the relationship. I'll just copy the previous block and make a few changes. This time, we're telling EF Core that each order product entry is also linked to a single product. And just like before, we used that with many, because a product can appear in many order product combinations. Finally, we set product ID as the foreign key that connects the join entity to the product entity. Now that we've configured the many-to-many relationship using Fluent API, it's time to apply these changes to the database. I'm opening the Package Manager console and running the add migration command to generate the migration file. I'll name it Add Order Product Table. I just ran the command, but looks like we've hit a build errors. Let's take a look at what went wrong and figure out where the issue is. Alright, so the error says order does not contain a definition for product. That's because earlier we had a product property, and we removed that property when we switched to a many-to-many relationship. The error is coming from the order DTO class. It still has a product property defined. For now, let's go ahead and comment out all the code that's causing errors, especially the parts that still reference the old product property inside order DTO or anywhere else. Once we've finished setting up the new many-to-many relationship completely, we'll come back and update those parts with the correct logic. Alright, I've commented out all the lines that were causing errors. Now, let's go ahead and build the application. Great, the build completed successfully. Alright, now that the build has succeeded, let's go ahead and run the add migration command again. Okay, looks like we've run into another error while running the add migration command. Let's take a closer look at what the error says and figure out what's going wrong. I see the problem now. The error is happening because, when defining the composite key in our Fluent API configuration, I accidentally used the order navigation property instead of the order ID foreign key. So let me fix that. I'll change order to order ID. This tells EF Core to use the actual foreign key fields when creating the composite primary key in the database. Alright, let's go ahead and run the add migration command again. This time it worked. The migration ran successfully, and the file has been generated. Now let's run the update database command to apply the migration and update the actual database schema. Let's run it and wait for EF Core to update our database. This command will apply all the changes we defined in our migration, including creating the order product table and setting up the relationships between order and product. Perfect, the update database command ran successfully. Now, let's switch over to the database and check if those changes have been applied. We should now see two new tables in the database, one called Product, which holds all our product details, and another called Order Product, which serves as the join table between order and product. As you can see, Order Product Table includes a composite primary key made up of order ID and product ID. Now that the tables are in place, let's go ahead and insert some dummy data into the product and order product tables to test our many-to-many relationship. Here, I am adding 3 products to product table. Next, I'm linking the first order to 2 different products. This shows how an order can contain multiple items using our join table. Alright, the data entry is now complete. Now, let's make some changes to our API so we can retrieve this data including the related products for each order. Let's go to our order endpoint now and update it to return the related product data. Alright, I'm going to update the getOrderById endpoint so that when we fetch a specific order, it also returns all the related products. Right now, getById async method and order service only fetching the basic order details. But since we've set up the many-to-many relationship, we want to also include all the related products for that order. So I'm going to update this query to include related data using YEF-Core's navigation property loading features. So the first part of this query is include order products. What this does is tell YEF-Core to bring in the related data from the order products table whenever we load an order. Then I chain ThenInclude product. This goes one step deeper for each order product entry. It tells YEF-Core to include the actual product entity related to it. Without these includes, YEF-Core would only return the order details and leave out all the related product data, which is not what we want. This setup makes sure that when we get a single order, we get the full picture, order info, and the list of products tied to that order. Now that we've updated the getById async method to include the related products, our endpoint is still returning the raw order entity, but that's not ideal. So let's go ahead and update the response to use an order DTO instead. We already have a toResponse extension method that maps our order entity to an order response DTO. Currently, our order response DTO includes just the ID and the product name. But now that we've expanded our model and relationships, it's time to update this DTO to reflect those changes. First, I'll add a simple product response record to represent each product in a clean way. This record includes just the essential details we want to return: the product ID, its name, which I've called product here, and the price. Now that we've defined the product response record, let's update the order response DTO to include a list of these products. Here, I've added a list, product response, called products. This will hold all the products linked to a specific order, each represented in a clean, minimal format. Next, I'm going to add a customer response property to the order response DTO. This will allow us to include basic customer details along with the order. With this change, our API response will now include the order ID, the customer who placed the order, and a list of products tied to that order, all neatly organized. Now let's go to the toResponse method and update it to match our new order response structure. We start by passing the order.id, which uniquely identifies the order. Next, we create a new customer response and pass the customer's ID, name, and email. This allows us to return just the important customer details in the API response, without exposing the full customer entity or any internal properties we don't need. It also makes the structure more readable and consistent for the front-end or client apps. Then, we move on to mapping the products. We go through each entry in order.orderProducts, which represents the link between the order and the products. Inside that collection, we use select to project each order product into a product response. From there, we access the product entity related to each order product link and pull out the values we want to return, specifically, the product ID, the name, and the price. Finally, we use toList to convert that sequence into a proper list and assign it to the product's property in our order response DTO. Alright, we've finished updating our toResponse method, and now it's time to go to our endpoint and actually use it. Now we're calling order.toResponse, which converts our order entity into an order response DTO. By calling toResponse, here, we keep the endpoint clean and delegate all the mapping logic to a single place, which is easier to maintain and reuse. Alright, everything is set. We've updated the entity, the DTOs, and the endpoint. Now let's run the application and endpoint to see if everything works as expected. I've set up the getOrderById endpoint in Postman, and now I'm going to send a request to test it. Alright, we just sent a request to the getOrderById endpoint in Postman, and we got a successful 200 OK response. The response body is exactly what we were aiming for. We have the ID of the order, followed by a customer object with the ID, name, and email of the customer who placed it. And then we have the products array. Each item includes the product's ID, name, and price. This structure is coming directly from our product response DTO, and it reflects the many-to-many relationship we modeled earlier. It shows that this order includes multiple products, and in this case, we've got a laptop and a pair of headphones. This confirms that our many-to-many relationship setup is working perfectly. We're pulling data from the orders, order products, and products tables and shaping it into a clean, user-friendly API response. So here's everything we've built in this video. We updated our entity models, configured the many-to-many relationship with order product, added clean DTOs like order response, product response, and customer response, and used Core's Fluent API to connect it all together. Then we tested the whole flow in Postman, and as you saw, it returned exactly what we expected: clean, structured order data with related customer and product details. This wraps up our demo on setting up a many-to-many relationship in Core the right way. But we're not stopping here. We've got more Core topics lined up. If you're enjoying this Core series, don't forget to subscribe and hit the bell icon so you don't miss what's coming next. Thanks again for watching, and I'll see you in the next one. Happy coding!